Red tide is a natural disaster caused by the overgrowth of certain species of microscopic algae, usually dinoflagellates, in coastal waters. This report provides an in-depth analysis of red tide as a natural disaster. The report begins by discussing the causes of red tide, including water temperature, nutrient levels, and wind patterns. It then goes on to discuss the impacts of red tide on the environment, the economy, and human health, including its effects on marine life, fishing industry, and public health. Finally, the report highlights ongoing research and strategies to mitigate the impacts of red tide. Red tides are caused by an overgrowth of certain species of microscopic algae, usually dinoflagellates, in coastal waters. These algae produce toxins that can harm marine life and, in some cases, pose a health risk to humans. The exact causes of red tides are not fully understood, but factors such as water temperature, nutrient levels, and wind patterns can all play a role. Water temperature is one of the main factors that can trigger red tides. Dinoflagellates thrive in warm water temperatures, typically between 18 and 30 degrees Celsius. Water temperature can also affect the speed at which the algae grow, with warmer water temperatures leading to faster growth rates. Nutrient levels are another factor that can contribute to red tides. Dinoflagellates require certain nutrients to grow, including nitrogen, phosphorus, and trace metals. High levels of these nutrients can lead to the rapid growth of dinoflagellates, which can then lead to a red tide. Wind patterns can also play a role in the development of red tides. Strong winds can create upwelling, which brings nutrient-rich water from the deep ocean to the surface. This can create ideal conditions for dinoflagellate growth and lead to a red tide. The toxins produced by the algae during red tide can have significant impacts on marine life. Fish and other marine organisms can die from exposure to the toxins, which can also accumulate in the tissues of these organisms. This can lead to the death of larger predators, including marine mammals and birds, that consume contaminated prey. Red tide can also have a significant impact on the ecology of the affected areas. The excessive growth of dinoflagellates can lead to a reduction in oxygen levels in the water, which can cause the death of many other marine organisms. This can create a cascading effect on the food chain, leading to the death of larger predators that depend on these organisms for food. Red tide can have significant economic impacts, particularly on the fishing industry. The toxins produced by dinoflagellates can accumulate in the tissues of fish and shellfish, making them unsafe for human consumption. This can lead to the closure of fisheries and the loss of income for fishermen and seafood processors. Red tide can also lead to a decline in the quality of the affected waters, which can affect tourism and recreational activities. Many people avoid swimming or visiting beaches during red tide events, which can lead to a loss of revenue for local businesses. The toxins produced by dinoflagellates during red tide can pose a health risk to humans. People can be exposed to the toxins through the air, such as by breathing in sea spray or aerosolized toxins. This can cause respiratory problems, including coughing, wheezing, and difficulty breathing. People can also be exposed to the toxins through the consumption of contaminated seafood. The toxins can accumulate in the tissues of shellfish, including clams, mussels, and oysters, making them unsafe.